Hello, my name is Claude. Some people know me. Today I want to present my current developments. I will start with a native video pass-through device called FrameStore, because it throws frames, and it's specially made for the PiStorm. And also present some other stuff I'm tinkering at my lab. Okay, let's show. Yeah, looking good. Okay, this is what I'm working right now. A FrameStore, then a proof of concept, FPGA, PiStorm hybrid thing, and a remote GPU for OpenGL rendering and maybe more for not only PiStorm but general classic Amigas. Okay. I'm start with the FrameStore. The goal of the FrameStore is getting the native video from the Amiga, where you usually have to use a second monitor or monitor switch, into the camera port of the Pi itself. That way you have a seamless switching between native and RTG video modes. And yeah. I killed a joke, okay. Okay. The challenge is the camera port is a quite modern interface. It's fast, very fast. You have to do this with 600 megabits, 1 gigabit, and so on. It's a complicated protocol, for me at least, and it's strange voltage levels. So my first thought was I take an FPGA. FPGAs are quite good for this, but FPGAs have a problem. They are nice when they work. You get in FPGA hell. You do debugging for weeks and nothing works, and it gets frustrating. Okay, this is, I made some screenshots about the camera protocol. It's quite a lot of things you have to obey, like voltage levels and protocol stuff and escape modes and on. And it's quite a lot. Okay. Oh, okay, I'm not really prepared. Okay, so it's good for FPGA. But I got in the so-called FPGA hell and stuck completely in development. But then Raspberry Pi presented a new microcontroller. It's a quite interesting microcontroller called RP2350 or something. And this microcontroller has very interesting hardware units. It reminds me quite a lot on the Amiga itself. A lot of DMA units, and it's simple, it's a nice chip. So I took this chip, it costs only $1.50. It has 2 ARM cores, it has plenty of memory built in. It has so-called PIO statement means. That's a little bit like a CPLD or FPGA, and it's ultra cheap, so I like this. Okay, that's the chip itself, and I did some tricks to sample the video of the Amiga in, convert it into the camera protocol, and yeah, I will show it. So, the Amiga video. I grabbed these video signals directly from the Denise or from the LISA chip digitally, send it into the processor with the PIO units, then doing some hand-coded assembly and stuff, and convert these video signals in real time to a 600 megabits per second video stream and send it over to the Pi. On the Pi, EMU68 runs, and we wrote a bare metal driver for the camera interface, and the camera interface then copies this directly with DMA without CPU involvement into the HDMI port. So it's ultra low level lag, low lag, no buffering. It's almost direct. Okay, then I prototyped some hardware. A little. No, the resolution is too low. It's just a handful of parts. It's the chip, it's some capacitors, some voltage regulators, and fits all on a small PCB. The PCB, like in all PiStorm projects, is open source. I will put it probably next week on GitHub, so everyone can download the files and send it off to a Chinese company called JLC PCB, and they solder the stuff for you, and yeah, you can order it. Oh, crap, okay. This is how it currently looks like in Amiga 500. The current development, I focus only on Amiga 500, Amiga 2000, and CDTV and stuff, where the video chip is in a DIL package. I hope till end of this year, over Christmas time, I find time to do this as well for AGA. I have a prototype, an alpha version on my stand, on our stand, and yeah. Okay, that's the frame throw. Release probably next week. On our stand is some demo units, and I can explain in detail also, if interesting for you. Okay. This is native video directly captured from Lisa. Captured then again from the Pi with an HDMI grabber. It's, I would say, pixel perfect. It's integer scaling, but you can also do smooth scaling to up to 4K resolution if you want. It has a built-in flicker fixer. So you can use interlaced modes up to high-res, not super high-res. Super high-res is better done with other products like InDivision. Yeah. And it's currently still a little bit rough on the software side, but it looks great in scrolling and yeah. I already, yeah, that's the timeline. OCS, ECS is ready now. AGA, I start next week, hopefully. And for existing scan doublers, flicker fixes, for example, if an InDivision or one of the great warp scan doublers, we have also something in the pipeline. On AliExpress or eBay, quite cheap HDMI to camera protocol converter boards. For this, we wrote a proof of concept driver, so can connect your existing scan doubler flicker fixer to the PiStorm and have the same functionality like with frame thrower, but you don't have to buy a new piece of hardware. You can use your old one just by using this cheap module. They start at 15 euros, 20 euros, around that. And yeah, it works. It's dpaint on RTG. So native in a window on RTG. Okay, that's about the frame thrower. Thank you. I'm a tinkerer. I wake up in the morning and think, would be good, would be great if I can try this. I don't know if I can do this. So I had an idea. Amiga is getting rare and expensive. So if you want today an Amiga 300, look on eBay, you only have one kidney. So yeah. So I started a little bit tinkering. I like FPGAs when they work, and I like PiStorm. So I started to combine two of my hobbies. Let's build our own Amiga. I'm using for that an existing project, Mist from Till Harbaum, for example, or Rock, or Dennis. There are many developers who contributed to the Amiga course on FPGA. So I took this great work, cut it a little bit on the side, and connected it to a Pi. With Emu68, of course, and made my first prototype of this. This also, again, a cheap Chinese FPGA board called Tang Nano, cost about 30 euro. Put it on a Pi 02, and this thing I called a Pocket Storm. It runs an OCS, ECS, Amiga core. Connected with the Pi 02, you get a quite okay Amiga 500 with ECS for about 50 euros, bill of materials. Okay, I'm tinkering, so I wasn't really satisfied with this because form factor, no USB and stuff. So I did a further prototype. This is the same concept, but now with USB plugs to plug in USB joysticks, keyboards, mice, everything, and one flat board. Yeah, that almost works quite okay. I have it also on demo on my stand, on the all stand. And yeah, but I don't like doing the mechanical stuff, like putting holes in enclosures. So I will probably change the form factor, make a mini ITX board out of this. So you basically have one flat board, one small size, cheap to produce, and put directly a so-called compute module 4 on it. That's our preferred Raspberry at the moment. It's fast, it's cheap. You can overclock it like crazy, like almost 3 gigahertz if you want. And yeah, I started with a PCB layout. It's ITX with 2 DB9 to connect the real joysticks. It's important for me. USB, HDMI, Ethernet, and so on and so on. This is currently on my bench. I'm tinkering it. Maybe in 1 year or 2 years I can present something which will work. Okay. I think last project. Amiga, classic Amiga, lacks quite a lot of graphic power in today's standards. There's OpenGL 1.x and Warps 3D as native AP, and getting GPUs or 3D acceleration for it is difficult. We have currently, as a side project, not our project, but Steffen Heuser and Gideon, maybe some know him, developing a native 3D driver for the GPU on PiStorm. I'm doing was similar something, but a little bit different, because I want to extend this probably to a Zorro card in the future, to plug in into a regular Amiga, and have also some sort of acceleration. Okay, the trick is relatively easy. You take a GPU, toss it in your Amiga, and download the drivers. Oh, crap. No Amiga drivers. Okay. Therefore, I think, it's hanging, sorry. Therefore, I did another approach. Currently only OpenGL, but it starts to work. I take a normal Amiga, then have the original OpenGL headers on the Amiga. I can link against them, or I can compile my stuff with them, and serialize the OpenGL commands and send them off to a different computer, a Raspberry Pi, or also my E9 at home, and this computer does the remote rendering. So I can use OpenGL 3, OpenGL ES4 for my Amiga 500 PiStorm at the moment, and render stuff, and can bring it then later maybe back with the camera protocol directly into the PiStorm, or make a whole graphic card for Zorro. Let's see. Yeah, some text stuff is not so interesting. But here is in action. I'm completely stuck at programming. So I managed to make an OpenGL cube moving. The application is running on the Amiga, and the screen is connected to a Raspberry Pi, which runs the remote OpenGL render. Yeah. And yeah, this is it. I'm a little bit over time. I have to give Michal, because Michal has really interesting stuff. And yeah.
Okay.
Thank you.
Oh, wrong slide. I'm sorry. Okay, let me start. Hi guys, nice to see you all around. So let me continue. Claude had made a very nice insight about the hardware, and I will continue with MU68 and a little bit also of hardware, your open source accelerator for your Amiga. So I'm going to talk today about three things. One is MU68.1.1, which is going to be released soon, and PiStorm 16. And finally, one more thing, I guess. It was known from the old times with the keynotes, there must be always one more thing at the end, and I'm also going to talk a little bit about something new and something different. Okay, guys. So first, MU68 1.1. MU68 was already pretty fast, but there is a problem. I mean, if we translate the Amiga or Motorola 68 code to the ARM code, I have to take the address of the code, make a hash number out of it, and then prepare a pretty huge table where I put the translated code into this table. The search is pretty fast already, but it could be faster, and it's not really so much optimal, because at the end you have the linked list of items which you have to search after the address and so on. It's all time consuming. I mean, it's just a fraction of nanoseconds, but at the end, if we want to make MU68 pretty fast, every nanosecond counts. So there was an idea of new cache, which is sitting on top of that, where we have 128 sets. Each of the sets has 4 ways, so it's pretty normal way set associative cache. And the nice advantage is that every single line of this cache can be fetched as a one transaction from the memory to cache of the ARM processor, which is fast, and then the search is just comparison of 4 addresses one after another. It's a very nice feature because this cache can be searched pretty quickly, and it is put on top of the other one. Every entry of this cache has two fields. One of the fields is the Motorola address with place for some cool stuff, which I will talk about later, and ARM address, so the search is pretty fast and pretty not so much time consuming. If the search fails, the normal cache, this hash table is searched for, and this small cache is updated with the new values, which brings an improvement in another run if the next portion of the code has to be executed. How does it look like? The performance improvement varies. As always in case of MU68, I mean, you cannot tell, okay, it makes, for example, 1%, 5%, 50% in general. It depends on the game, it depends on the software you are running. But I have made some tests already, and I was testing, for example, Quake and Heretic 2, also the Settlers. And in case, for example, of Heretic 2, it was pretty funny because I was discussing with Stefan the results of my measurements, and we just have a look, okay, the resolution, frame rate, and so on. Oh, it's pretty the same. There was actually no change, so there is no benefit until the point where we have looked, okay, the previous experiments or the previous measurements which were done by someone else were done with CM4 running not at 1.8 gigahertz as it was in my case. It was CM4 overclocked to 2.2 gigahertz. So it gives us more or less 20% performance improvement, which means I have a clock of Raspberry running 400 megahertz slower than previously at the same frame rate, which is already pretty nice. I mean, it's finally the discussion, do you like to play the Quake in, I don't know, 800 times 600 or 1200 times something? I mean, it's yeah, very nice, but let me continue to another way, to another part. I've told you that every line of the cache has a nice field for the cool stuff, and the new cool stuff, which is coming in MU68, is this one. You know this guy, right? The dumpster, every time when Motorola was going to flush the cache, I was just removing everything what was there because, I don't know, if it has to be flushed, if it has to be removed, I just said, okay, let's remove it, it's fine. But why removal? I mean, in many cases, for example, if you execute the code from Amiga ROM, will it change during the runtime of Amiga OS? No, not really. If you, for example, load some library, will this library change usually if you flush the cache? No, not really. So instead of flushing the entire cache, maybe there is a different way to do that. Especially, not because of Amiga OS, because on Amiga OS, every time you load some kind of executable, Amiga OS says, flush the cache. We don't need it anymore, it has changed, remove everything, start from scratch. If you would like to run, for example, Shapeshifter, it's running a little bit different way. It's flushing the cache every 20 milliseconds, every 100 milliseconds. It's absolute overkill. They have decided to do that way. It's painful for MU68. For normal Motorola processor, it's not really a problem because you have 16 kilobytes of cache. In case of MU68, I have 64 megabytes of cache. If you flash it 10 times, 50 times per second, it's really painful. It's removing all the gain from MU68. So the cool stuff field is the epoch. Every time I flash the cache, instead of removing everything, I just increase this number, which means the next search for my block, for my translated block, will fail, because this number has changed. But then I look again for the cache, looking for the block without this number, ignoring the number completely. I can verify if the code has changed. I'm calculating the checksum. If it's the same, fine, we recover it, we update the fields, it's done. If it has changed for some reason, because, for example, the executable was loaded, it's removed, just like that. Two advantages. One, I don't have to recompile every time, which gives me a speed boost. The second one, if I flush the cache, no matter how full it is, it's just a single operation, increase the number. Not for every item in the cache, one number, which means the speed boost is doubled, so to say. What does it mean for us? For example, with MO68, the new version which will appear, I hope, I don't know, maybe 1-2 weeks from now on, the workbench is booting faster, something like maybe 2 times faster. macOS is starting now in seconds. What has took previously something like 1 minute to boot macOS 8 point something, for example, is now happening in 10 to 15, 20 seconds maybe. So the speed improvement is really huge, and this is something I really like. Okay, that's MO68 1.1. Yeah, thanks. So I also like to play with the hardware sometimes, and my Amiga 600 was using the old PiStorm with Raspberry Pi 3 or something like that. I was always wanting to run it with something faster, P4 or CM4, for example, and that was the idea for PiStorm 16. This little guy, I mean, this one is not populated by on our stand. I have one in my Amiga 600. So it's the PiStorm, the new version, which is based in principle on PiStorm 32 Lite, with the same FPGA on board, designed for Amiga 600, where you can plug in your CM4, for example. You have also the outputs for the network interface, for the HDMI, and also the CSI camera input port, which is planned to be used with the frame thrower. Yep, you know the guy. And yeah, the development is in principle ready. The design, as everything we do, is open source, open for everyone who like to use it, who like to build it, sell it, whatever. Should be available on GitHub in a few weeks maybe. There is already one company from Poland which is building this PiStorm and going to start with selling the PiStorm soon. Of course, it was pretty painful to start with because I have almost destroyed my Amiga 600. I've made a mistake, then I had to fix the mistake, check if the new design will work, but it was pretty a lot of cables and pretty a lot of sweat on my head and on my rack, on my behind, because I was just shocked if the Amiga will still be alive after removing the PiStorm with such a mistake. Okay, that was the hardware, that was the software. One more thing. I mean, since the very beginning of MO68, people were asking me, would you allow to run, for example, ARM code on the Raspberry? Because you have CM4, you have the ARM processor, why not run ARM directly on it? The problem is, what ARM? Yeah? I mean, the family of ARM processors is pretty bright. You have ARM 32 bits, 46-bit, you have the thumb2 instruction set, then you have the A profile, which is application processor, you have the M profile, which is for mobile, you have the R profile for real-time. Finally, you can run ARM processor in big endian, little endian mode. Which one would you like? I mean, not everyone, because there are already some turbo cards for Amiga which have ARM processor, which maybe not support anything out of that. Maybe there are some limitations. Okay, I'm trying to do myself as fast as possible. But we had already some foreign architecture in our Amiga, which was not the 60K processor. We have something what was Xeno, what was using very, very funny instruction set with very, very funny instructions names like something like that or something like that. I don't know why it sucks. They just decided to name it that way. Okay, MO68 is going PowerPC. Sorry for that. There are a few advantages. I mean, the PowerPC alone is a RISC processor, which means the translation is much easier. The translation is straightforward. The instruction set is pretty similar. In most cases, it's one-to-one translation. Every single PowerPC instruction is every single ARM instruction. An example here, you have the code, which is already a little bit reduced because some of them were abundant. You see on the left side the PowerPC instructions, on the right side instructions translated by MO68 already. As you may see, the compiler has decided to unroll the loop 4 times. MO68 is repeating this procedure even more to gain the speed. Almost ready. Yeah, so what's the actual status of PowerPC for MO68? It's more or less 95% ready, the integer part. I'm missing I don't know, something like 3 or 4 instructions. FPU is not yet started. It's planned for the future. Altivec is not going to be implemented because it gives another set of 32 registers, which are pretty huge. I don't have the space on the ARM processor for that. PowerPC library, which is going to be compatible with Warp OS, is work in the progress. It's already partially working. I've started on that. Interrupts are working. The PowerPC processor can communicate with Motorola processor and the other direction also. And very important also, both translators run on separate CPU cores, which means the Motorola 68K does not have any disadvantage because of the PowerPC, and on the other way around, PowerPC has no disadvantage that the Motorola 60K is working also in the background. And very nice feature of ARM processor, the cache, the whole data cache is coherent at all times, which means the problem which we had on the PowerPC Blizzard or whatever cards for Amiga 1200 is not existing in this case. We don't have to flush the cache all the time. The cache is staying all the time coherent. The last part, the numbers. It's pretty fast. So the first day, the tests gave me up to 1.8 PowerPC instructions translated in single cycle or executed in single cycle of ARM processor. This includes the whole loop of MU68, so it's not only the piece of code, it's everything together. And the performance can go as high as in case of my test. It was pretty shocking for me, 3,600 MIPS on my standard CM4. And this is not the last word because it was without any kind of optimization. I mean, I'm trying to first make MU68 with PowerPC running. And once it's running, I'm going to optimize it even more. Yeah, so this is how it looks like. If you like our work, use it. We love when you use M68. We love when you use PiStorm. We are very happy with that. Our projects, all projects are open source, available on GitHub. If you like our job, you can support us if you like. If you don't like to support us, it's also great. Just be happy with whatever we do. And yeah, thank you for your attention.